Hi, this is a continuation of our topic on limits. So now you have here the expression 2z squared minus 3z minus 2 over z minus 2. Now take the limit of this expression as z approaches 2. Now we can factor this numerator using the technique we have discussed on the previous video. This is 2z squared minus 3z minus 2. Okay, what we can do here, let's try to find the product of 2 and negative 2, the leading coefficient of 2 multiplied by the constant negative 2, that will be negative 4. Okay, and then look at this coefficient of the middle term, negative 3. Basically, what we need to do is we need two factors such that the product will be negative 4 and the sum will be negative 3. So negative 4 comes from the product of 2 and negative 2, while negative 3 is the coefficient of the middle term. So here, let's say 1 multiplied by negative 4. So 1 multiplied by negative 4, you will get negative 4, and we add them. Let's say 1 plus negative 4. Now here you'll get negative 3. So here you can now express 2z squared minus 3z minus 2 as 2z squared, using now these two factors here, negative 4z plus z minus 2. Take note, this negative 4z plus z is just basically negative 3z. So you're not changing the original numerator. You're not changing this expression here, because 2z squared minus 4z plus z, this minus 4z plus z is actually equal to negative 3z, which is our original middle term. And then, of course, you have here negative 2. So now, let's now get the factors of this, or the greatest common factor of this first two terms and the greatest common factor of the other two terms. So here, the greatest common factor of 2z squared minus 4z will be 2z. So 2z, okay, so 2z squared divided by 2z, we will get z. And then negative 4z divided by 2z will give you negative 2. Plus, so the greatest common factor of z and negative 2 will just be 1. So we'll just rewrite this as z minus 2. We'll write it as is because the greatest common factor is only 1. Now, the greatest common factor now of this entire expression is z minus 2. So z minus 2, okay. Now, we factor this first term, 2z, z minus 2, divided by z minus 2. So this will now be 2z, and then this one, z minus 2, divided by z minus 2, you will get 1. So what we did, we factored out the greatest common factor of this expression, which is z minus 2, and then this one now is multiplied by 2z plus 1. So now we can express this numerator as z minus 2 multiplied by 2z plus 1 quantity. So now let me rewrite the expression as the limit of z minus 2 multiplied by 2z plus 1 over z minus 2 as z approaches 2. Notice here that z minus 2 can be cancelled, and you're now left with the limit of 2z plus 1 as z approaches 2. So let me write this as the limit of 2z plus 1 as z approaches 2. This is now equal to 2 times 2. If we substitute z is equal to 2 plus 1, this is now equal to 4 plus 1 is equal to 5. So our final answer will be 5. Now, let's see another example. We have here now a radical expression, square root of z minus 3 over z minus 9 as z approaches 9. Now, if you see something like this, wherein there's a radical expression, what you can do is we need to rationalize it. So what we can do here is the limit, let's rewrite it, limit of square root of z minus 3 over z minus 9 as z approaches 9. If you recall, we have the difference of two squares. A squared minus b squared is equal to a plus b multiplied by a minus b. Now, so the square root of z minus 3, we can treat this as a minus b. So let's have a plus b now. So this will now be equivalent to square root of z plus 3. Of course, to make it equal to 1, this fraction here, we have to have square root of z plus 3 here as well. So that square root of z plus 3 divided by square root of z plus 3 is basically equal to 1. So we're not changing this original expression. Now, you can see here, square root of z minus 3 multiplied by square root of z plus 3 is basically equivalent to a plus b, a minus b. So this a minus b is equivalent to the square root of z minus 3, and this a plus b is basically equal to square root of z plus 3. So in this case, you can now express this expression here as a difference of two squares. So what do? We take the square of this minus the square of this. So we get now, what we get now is the limit of the square of square root of z will just be z minus the square of 3 will now be 9. So this whole expression here is basically the square, the difference of two squares, z minus 9. So over z minus 9 multiplied by the quantity square root of z plus 3 as z approaches 9. Now, as you can see here, these two terms, they cancel. Now, it leaves you now to the limit of 1 over square root of z plus 3 as z approaches 9. So now if I substitute now z with 9, I will now be getting 1 over square root of 9 plus 3 is now equal to 1 over square root of 9. Square root of 9 here will be 3 plus 3. So this is now equal to 1 over 6. So our final answer here is 1 over 6. Now, we have another example here. Limit of x minus square root of 3x plus 4 over 4 minus x as x approaches 4. So, similar technique that we did a while ago. This is a radical expression. So what we do, we need to rationalize now this one. So what we can do here, again, similar to what we did before in the previous example. Remember, a squared minus b squared, the difference of two squares, is equal to the product of two binomials, a plus b multiplied by a minus b. So we do the same technique here. Let's write it now. The limit of x minus square root of 3x plus 4 all over 4 minus x as x approaches 4. So we multiply this now by x plus square root of 3x plus 4 over 4 minus x. Let me just clean this up a bit. Yeah. So what do we get here now? X minus square root of 3x plus 4 multiplied by x plus square root of 3x plus 4. This can now be x up. Sorry, let me just... So here, the denominator needs to be x plus square root of 3x plus 4. Why we did that? So that this will be, basically, since the numerator and denominator is equal to 1, basically, you're not changing this original expression. So we can, as long as the numerator and denominator are the same, then basically just multiplying by 1. So it's okay. It doesn't change our original expression. So here, this can now be expressed as the limit of, we take now the square of this, which is x squared, minus the square of this, which is now 3x plus 4, divided by 4 minus x multiplied by x plus square root of 3x plus 4 as x approaches 4. Now let me just clean this up a bit. So we have more space to work on. So here, this is a negative sign. What we can do here is we can now change this into the limit of x squared minus 3x minus 4 over 4 minus x multiplied by the quantity x plus square root of 3x plus 4. Okay? Now, don't multiply this, okay? Don't touch this. Don't change this. So x approaches 4. Now, again, let me clean this up a bit to have more space. Now, if we look now at the numerator, this can be factored. So we can write it here as the limit of, can be factored, and it can be expressed as a product of a binomial, of two binomials. So x here, x here. So let's say this will be negative 3, for example, and or let's say not negative 3. Let's let me delete that. Let's say negative 4 and plus 1. Let's see. So x times x will be x squared. Negative 4 times 1 will be negative 4. Negative 4x plus 1x, you'll get negative 3x. So this is correct. So divide this now by our expression 4 minus x multiplied by x plus square root of 3x plus 4. But take note, this 4 minus x, if you factor out negative 1, this actually becomes x minus 4. Okay? Now, if you multiply negative 1, it will be negative x plus 4. This is basically this one. So by factoring out negative 1, you'll get x minus 4 here. and of course multiplied by x plus square root of 3x plus 4. Now, notice here, you have x minus 4 in the numerator, you have x minus 4 in the denominator. These two will cancel out. Don't forget, by the way, to put x approaches 4. Now, since these two canceled out, now you will have the limit of x plus 1 over negative x plus square root of 3x plus 4 as x approaches 4. Now, let me just clean this up to have some space. Sorry. Put this line here. Let's put a divider here. Yeah. Now, if now substitute x by 4, we now have here 4 plus 1 divided by negative 4 plus square root of 3 multiplied by 4 plus 4. This is now equal to 4 plus 1 will give you 5. There's a negative sign here. Let's just put it upstairs. 4 plus square root of 3 times 4 is 12 plus 4, 16. Square root of 16. This is now equal to negative 5 over 4 plus square root of 16 will give you 4. Now, our final answer will be negative 5 over 8. So, that's it, folks. We don't have much time. I'll give you more examples in the next video.